Okay, I just need to go through this one example here in the middle, square root of 16 over 3. And I did not go over this in class, the fraction ones, so I just want to do a little quick recap of it. When you have a fraction, kind of like when you have two things multiplied, you can split them apart. So I can take the square root of the top over the square root of the bottom. Well, we know that the square root of the top is 4, so that gives me 4 over the square root of 3. You can't leave, I'm sorry, let me erase that. You can't leave, I don't know what I'm trying to write here, square roots in the denominator. Okay, so this is called rationalizing the denominator. I don't think there's an I in there. I don't even know what I'm doing right now, guys. I suck. So to clear it out, to get rid of this square root, we're going to multiply it by itself. This is called rationalizing the denominator. The reason we want to multiply it by itself is because if you take the square root of 3 times the square root of 3, that's, if you multiply something by itself, that's the same thing as taking the square root of 3 and squaring it. And everything we've been talking about for the last couple days says that if you square root and square something, they cancel each other out, and it's just going to leave you with the 3 in the bottom. So what's going to happen is, if I have a square root of 5 in the bottom, I'm going to multiply by the square root of 5, so that the square roots cancel, and I'm just left with 5. If I have square root of 10 in the bottom, I'm going to multiply by the square root of 10, so that I can just get 10 in the bottom, okay? And I'm going to show you another one here in a minute, so it'll make a little more sense. Whatever you do to the bottom, you have to do to the top as well. So then I do 4 times square root of 3. Anything on the outside can only multiply by itself on the outside. So 4 times 1 is 4, and then radicals multiply by radicals. Well, the first one didn't have a radical, so it's just 4 square roots of 3, and that's your answer. We're going to try another one, and if you need to pause and go back, whatever, because I kind of just quickly went through that. Let's say I give you the square root of 8. Let's do the square root of 2 over the square root of 5. Okay? I can't have a square root in the bottom. So I'm going to have to multiply the top and the bottom by the square root of 5. The reason I'm picking the square root of 5 is because when I take the square root of 5 times itself, that's the same thing as taking the square root of 5 and squaring it. Square roots and square roots cancel, and I'm just left with a 5 in the bottom. But to keep a fraction equal, you have to do the same thing to the top. So I'm going to multiply by the square root of 5 on the top. Anything inside a radical can multiply by things inside a radical. These are both inside, so 2 times 5 is 10. And that's your answer there. The 10 and the 5 do not reduce here because one is in a radical and one is not. If it's in a radical, it does not interact with anything outside of a radical. And that's how you rationalize the denominator. That's going to help you on a couple of the top portion in the worksheet that I gave you on Tuesday.